Breaking news! Scientists, chemists, and historians have discovered something extraordinary, a brand new country. It is called the United States of Matter, and on today's special edition of Universal News, we will share all the wonderful aspects of this new country. Let's get started! Now, in the United States of Matter, 3 states have been discovered. These states are called solid, liquid, and gas. Let's begin with the solid state. Now, solid is a very rigid state. The people there, known as particles, are really slow. This is because in the solid state there is a massive population of particles. Because there are so much of them, they live and move very closely together as if they are only vibrating, which in fact they are. Now you may be wondering whether or not it's hard to live in the solid state because of its overpopulation. And yes it is, but there is a positive side. The fact that particles in the solid state are so closely together makes them have good relationships or forces. This is known as their intermolecular forces, the forces that connect the particles together. That's real neat, don't you think? Now let's get back to talking about the liquid state. The liquid state is very flexible and water-like. The particles in this state easily fit in but live more farther away from each other than the particles in the solid state. It is the second most populated state after solid. Because of that, their intermolecular forces are slightly weaker than those between the particles in the solid state. They also move in a faster random motion. However, they still are close enough to hold good relationships or bonds, and they only break under certain circumstances, which we will get into later. Now, the last discovered state of the United States of Matter is a gas state, sometimes referred to as the gaseous state of matter. Particles in this state move very quickly and randomly. They are the least populated of the states because of how much space is between them. Because of the massive amount of space between them, their intermolecular forces are very weak. The particles rarely have time to talk to each other because of how fast they move and how weak their relationships are. Isn't it cool how particles can all be living in the US of M, but seem very different based on their state? What a diverse new country. Remember how we talked about those certain circumstances that could change the particles that live in one state to live in another? The intermolecular forces breaking? Those special conditions are known as phase change, or the change of particles from one state to another. It is basically when particles travel for business, vacation, or just about the same things that people travel for here in the United States of America. For example, if a particle wants to travel from the solid state to the liquid state, he or she will need to go through a process called melting. Similarly, if the particle wants to return back from the liquid state to the solid state, he or she must undergo a process called freezing. Basically, a particle must go through a process such as melting or freezing to travel or change from one state to another. Other phase changes include vaporization, liquid to gas, condensation, gas to liquid, sublimation, solid to gas, and deposition, gas to solid. Now, in order for the particles to actually travel from one state to another, and for their specific processes to occur, a transfer of energy or heat needs to occur. Basically, in the United States of Matter, there is only one temperature, hot. Now, depending on the situation, the heat could either be released or added. When it is added, it is known as endothermic, while when it is released, it is known as exothermic. So, for example, if a particle from the gas state wants to travel to a liquid state, condensation must occur. Condensation is exothermic, meaning that the energy from the particles in the gas state is being released to cause it to be in the liquid state. Once it is in the liquid state, the particle will adapt to the qualities and features of the liquid state and will stay that way until a phase change occurs again. This happens to all other particles while undergoing other types of phases. Now, like I said before, once the particle has traveled to another state, it will immediately take on the customs of that state. For example, if a liquid were to travel to the gas state, it will become more distant, more faster, and more moving in a random motion. This happens because the intermolecular forces are changing, specifically either breaking or building up. For example, a solid particle traveling into the gas state through sublimation will have its intermolecular forces broken down. Once it returns back to the solid state, its intermolecular forces will build up again. This is known as a physical change because the particles keep the same composition as before they changed even after they had phase change. It wouldn't be a chemical change because it is the same particle traveling and it didn't change properties. In fact, it is actually easier to transfer energy in the solid state because its intermolecular forces are so strong. In the liquid state, it is still easy, but there is less transfer of heat or conduction. In the gas state, it is very hard because of its weak intermolecular forces. Well, we are going to wrap up the special edition of Universal News about the United States of Matter and the new founded country with 3 states, solid, liquid, and gas. They can only be seen at the microscopic level, however, and what us humans see is just the macroscopic levels. The solid state, a rigid substance, the liquid state, a more relaxed substance like water, and the gas state, hard to see even at the macroscopic level. At the end, we congratulate the founders of the United States of Matter and how much they contribute to our findings. There is even some possibilities for a new state that is being found. It is called plasma, but we will have more information in the next episode of Universal News. Thank you for watching and good night.